All right, going to continue our discussion with some examples. And again, this is a related rate. We'll talk about y in a second. A 5-foot tall person, he's actually shorter than me, is walking towards an 18-foot tall lamppost at a rate of 2 over x feet per second, where x is the distance from the person to the lamppost. So the further from the lamppost he is, the slower he walks. And the closer he gets, the faster he walks. So you can think of it this way. He's going towards the lamppost at a crawl, and then pretty soon he's getting closer, closer. Pretty soon he's really like jogging toward the end. At 1 foot away, he's going 2 feet per second. And at the very end, he's, at half foot away, he's going 4 feet a second. But again, when he's a ways away, he's kind of moping his way there. Assume the scenario can be modeled with right triangles. Again, because the person and the lamppost are at 90 degrees to the flat world. At what rate? Okay, there's the related rate. At what rate is the length of the person's shadow changing when the person's 15 feet from the lamppost? All right, so we got to picture some things here, and I'm going to draw this from scratch. I have a diagram here we're going to pull up in a second. We have a light post that's 18 foot tall, all right? And we got a lamp up on top. And some distance away is some 5-foot guy in green. And it said you can model it where this distance in red is x. And we know he is going this way at 2 over x feet per second. That's how fast the green guy's moving. And his shadow is being cast behind him from the light, and I'm going to call that y. And there's our triangles. And if I mark the right angles in purple, I can now see I have some triangles going on. And it said he is moving towards the light post. And this is the big deal. You have to see at this point, because of these things, x dx dt, 2 over x, is negative. It's making x smaller. So we talk about our knowns. Have dx dt equals negative 2 over x. And they want to know how fast the person's shadow is changing. In my case, I called it y. So dy dt is the unknown when x, his distance from the lamppost, is 15 feet. Now, do not plug in 15 feet and start calculating y. It didn't ask for the length of the shadow. It asked how fast it's changing. I don't know if I need that information. There's no reason to calculate it yet. All right, so, and that's the same as the figure I had. So here we sit. So we have to write a relationship here. And to do this, we have to see the right triangles. Now in black, I see the first triangle is 5 over x. Also y plus x over 18. Those are your two right triangles. And I know the ratio, since they're similar right triangles, are equal. So I would write that as 5 over y. And this is y, not x. Sorry, length of the shadow y is equal to 18 over x plus y. All right, I cross multiply and make a couple of equations which I can solve. And I did that here. 5 times x plus y is 5x plus 5y, and 18 times y is 18y. Move 5y to the other side, and I got 5x equals 13y. And the question I got to ask myself at this point is that, can I live with those variables? I know dx dt. I know when x is 15. I know the rate here. I know dy dt is my unknown. I know I can find this now. I don't have to eliminate a variable. So what I can do now is I can differentiate 5x equals 13y. If I do that, I get 5 dx dt equals 13 dy dt. Now, if dx dt was linear, or not even linear, if dx dt was a constant, dy dt would also be a constant 5/13 of it. But that's why they made this a negative 2 over x, so it varies as it comes closer. All right, I realize I know dx dt. I'm going to slide some of my equations up to the top so we can see everything that's going on. All right, I know my dx dt, and I know I'm searching for dy dt. So I will plug in, and I guess initially it was 2 over x here, right? 5 times negative 2 over x feet per second equals 13 dy dt. And again, the 5 and 13 were unitless, all right? So, but I know it asked me to find dy dt when x was 15. So I can plug that value in. And think about it, you look at it now. Now it's just solving for dy dt. If I do that, I get dy dt equals negative 239 foot per second. Again, diagram, identify the known and unknowns, find a relationship or an equation for the situation, and then differentiate with respect to time. All right, related rates, keep practicing.